Okay, so graphing points and relations, we need to review some definitions. So the first one is, what is a relation? So the last couple of years, junior high math, you've been talking about relations. You've talked about sets of ordered pairs, tables of values, and you've plotted some points. So that's what we're reviewing today. So a relation is a relationship between two sets of values. It can be represented as a set of ordered pairs, table of values, equation, or a graph. Most commonly, we use x and y as the two variables in the relation, where y depends on x. Thus, y is called the dependent variable, and x is called the independent. Sometimes in different applications, maybe it's number of tickets and the cost. Well, cost depends on how many tickets you buy. So tickets is independent, cost is dependent. So it doesn't have to be x and y, but x and y is sort of our default variables. An ordered pair, if we're thinking about x and y, think of the alphabet. X comes before y in the alphabet, so the x value is first. Students get it mixed up. Horizontal axis, when you're doing a graph, always represents the independent variable. Okay, the x value. There are situations where maybe you tip it on its side, but for the most part, and what we're doing in grade 10, it's independent on the horizontal, dependent on the vertical. And just a reminder that the word that we give, a special name that we give to 0, 0 is the origin, because that's really the center. If we take a look at the down here, the origin is right here of those two number lines, the x-axis and the y-axis. Okay, so things to remember for horizontal is x, vertical is y. We don't know that it's necessarily x and y here. We've just got the ordered pair. So independent is first, dependent is second. Taking a look at this, remember that positives go to the right of 0 and negatives go to the left. Positives above, negatives below. Vertically, you think of a thermometer. If you ever look at a thermometer, it gets hotter, it gets bigger, right? When it's cold, it's below 0. So x value is always first, so we go 3 units over, and we'll assume that one grid is 1 unit. So 3 units over and 4 units up is point A. Okay, so plot that. -2 is 2 to the left, and then 6 up. Zero, 5. 0 is the x. So remember, this is 0 for x and for y. So 0 for x, 5 for y. So anytime you have 0 for the x value, you get a point on the y-axis. We call it a y-intercept. -7 for x. -7, -3. Then this one has 6 for x and 0 for y. 6 for x, 0 for y. Then 5 for x and -5 for y. So hopefully that makes sense to you. Positives to the right of the origin, negatives to the left. Positives vertically upwards, negatives vertically downwards. Okay, so I want you to do B. State the coordinates of each of those points. I've helped you out by putting brackets already. When you have to do it by yourself, you have to remember to put those brackets. Okay, so you're doing those right now. David, are you going to get started? Well, how are you going to get one? Do you want to ask me for one? Yeah. Quickly, sign now. Okay, so check those. I'll make that 4 look a little bit better. Oops, no, okay. It's wrong if you interchange them. So always remember X value first or independent first, Y value second. So next one, take a look. I gave you a hint here. Think about the scale. So if I look horizontally, 1, 2, 3, 4, 5, 6, 7, it goes 7 in each direction, but I've got bigger than 7 in some of those X values. So then you have to have equal scale. So let's go by 2s. Little bit, you don't have to label every dash. So if I go by 2s, the first would be 2, the second would be 4, 6, 8, 10, 12. So at least we can see the pattern and it's not too squishy for you. So then -4, -8, -12. And then same vertically. So 4, 8, oops, let me fix that one up. And then -4, -8, -12. Okay, so now we can plot. So 10, 4. 10 would be halfway between 8 and 12, so that grid marking, and 4 up. So that's going to be A. -12, 6, halfway between 4 and 8. 0, -12, so that's a y-intercept. It's on the y-axis. And then 9, well, 9 is halfway in between 2 grid markings, so you have to basically estimate halfway and then down to -10. So be careful on that one. It's in between 2 grid markings. Oops, sorry. Oh, what just happened there? Okay, it just deleted a page. So hold on a sec. Edit, undo add page, edit, undo delete page. There we go. Okay, last one, all that's different is the values are in a table of values. So really, your ordered pair is -6, -5, -4, -2. Those are your ordered pairs. And we don't have to label with A, B, C, D, E, right? You just plot the points. None of those are bigger than 7, none of the values. So I'm just going to use, if every grid is 1 unit, then you don't have to label the scale. So 1, 2, 3, 4, 5, 6 to the left, 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 1, 2 down, -2, 1, 0, 4, and 2, 7. What do you notice about those points? What's special about them? They make a line, yeah. So we're going to talk more about that, particularly tomorrow. But that relation is called a linear relation because if you put a ruler up to it, all the points would lie on that line. Okay, and we can actually come up with an equation for it as well. All right, but we graphed from a relation from a set of ordered pairs from a table of values, and now here we're going to do it from an equation. Okay, so it says a relation is represented by the equation y equals 2x minus 3. Is your earbud off? Is that off? Where x is any real number. Use this equation to complete the table of values and then plot the points. So when I say that x is an element of the set of real numbers, it means it can be any decimal or fraction. Okay, but in the table of values, I've just chosen integers. But if it can be any decimal fraction, that means we're going to be able to find more points than what I just listed there. In any case, let's figure it out. So when we have -2 for x, that means we have to put -2 in for x and figure out what y is. It's the order of operations. So that says 2 times -2, so that's -4 minus 3 is -7. Okay, so you're going to do that with every point. And if you need to scribble on the side to show your work, go for it. I'll do the next one. So that was y equals. So then y equals 2 times -1 minus 3. So multiplying first, then subtracting, that's going to be -5. Okay, then put 0 in. Well, anything times 0 is 0. So that's just going to end up being -3. Okay, now put 2 in. Do it down here. Y equals 2 times 2 minus 3. So order of operations, I've got to multiply first. So that's going to be 1. And then when x is 4, y equals 2 times 4 minus 3. So that's 8 minus 3 is 5. And now plot those points. So -2, -7. I'm just going to actually move. Oops. I'm going to actually move. Okay. Or not move. I'm going to erase this so I can see my graph better. So -2, -7, -1, -5, 0, -3, 2, 1, and 4, 5. Okay. If you were to put a ruler next to those, would they be on a straight line? Looks like it, yeah. Okay, and in this case, it says, does it make sense to join the points? Well, if we've put in here that x is any real number, then, because we don't know what the relation is, like what is x representing? Is it number of people or tickets or whatever? We don't know, but it says x is any real number, so that means a decimal or a fraction. So that means yes, we do join them. Okay. All right, so now we'll get into some applications. So these are relations that actually have an application. It says the graph shows the relationship between earnings E and time worked T. Use the graph to help you complete the table. Okay, so we don't have an equation, but we have the graph. So we've had ordered pairs, table of values, equation, and now a graph, just like I listed in the beginning. So when t is 2, you want to look at your graph, and you go up to the graph and go across, and the earnings are 30. Okay, $30. Now, when earnings are $60, you go across and down. That's for 4 hours. 6, we go up and across. That's 90. Okay, and then 105. Well, look at the scale because I don't see a marking for 105, right? So these are 30 apart, so it's 15 for every grid marking. So this would be 105 there. So we go across and down, and so that would be 7 hours. So what do you think the rate of pay is? 2 hours, you get paid $30, right? $15, right? Because 30 divided by 2 is 15. 60 divided by 4 is 15. 90 divided by 6 is 15. 105 divided by 7 is 15. So that really is going to give you the equation. It doesn't ask for it, but what it would be is E equals 15T. So you put in the number of hours, you multiply by $15 an hour. That's minimum wage right now, right? So what are the coordinates where the graph intersects the vertical axis? So where does it intersect? Right at 0, 0. Okay, what's the meaning of that point? What does it mean in this context of this question where T is time, E is earnings? If you work 0 hours, do you get paid? No. Okay, only time you might get some kind of pay is if, say you have a salary job, and we'll talk about that later in the course, where you get paid, but maybe you take your vacation time, then you're still going to get paid. Or a commission where you get a base amount even if you don't sell anything. But in this case, meaning is if you don't work, you don't get paid. So you don't earn money. Okay, next application. You are walking to school at a rate of 100 feet per minute. Complete the table of values and then graph the points. So take a look here. Always important to look at the units. That's 100 feet per minute. And we're asking you to find how many feet in 30 seconds. Well, what part of a minute is 30 seconds? Half a minute, right? So really you might want to put 0.5 here. 60 seconds is 1 minute. 90 seconds is how much of a minute in decimals? 1.5, yep. And 120 is 2. So that's really what we're going to multiply by 100. So 0.5 times 100 is 50. 1 times 100 is 100. 1.5 times 100 is 150. 2 times 100 is 200. Pretty straightforward multiplications. And now I want you to plot those points. I've done the scale for you, so it shouldn't be too difficult to plot them. Then think, does it make sense to join them up? Okay? If you're walking to school, does it make sense that you jump from this point to another point after 1 minute, another point after 2 minutes? Can you travel in time? Nope. So you have to continuously keep walking. Basically, any time the independent variable is time, it's likely a continuous function where you join up the points. So here I'm plotting just these ones. So half a minute is 50, 1 is 100. And now in this case, I'm going to join those up. Okay. I'll put an arrow on the end because technically you can keep walking forever. Now, in this case, are we walking at a constant pace based on what the information is given? Yeah, always 100 feet per minute. Now, obviously, you're walking for hours and hours. That's probably going to change because you're getting tired. But at this point, that's the information we have. Okay. Yes. Time is continuous. Okay, so now using the graph, if you've walked 275 feet, approximately how long? So you want to look at the scale. We go from 200 to 300, so this would be 250, and so 275 would be halfway in between. Okay, and so that here is 2.5, and so that's going to be 2.75 minutes. Kind of makes it easy when it's 100 feet per minute. You're just dividing by 100. And just like we did the equation, although we weren't asked for in the last one. In this case, distance will equal the rate that you're walking times the time, and where t is in minutes. Okay. Yep. Oh, for seconds? Yep. So you can do, if t is in seconds, oops. So if t, so let's, yeah, if t is in seconds, not t over 2, spelt that wrong, because there's 60 seconds in a minute. So we would go d equals 100 divided by 60 times t, right? So if you think about that, if you put t equals 60 in there, that's 1 minute, so you should get 100. They would divide out. Now we can simplify that to 10 over 6, which reduces to 5 over 3t. Okay. If t is measured in seconds. So it's a little bit different. That's why I just did the t in minutes, because that was the way the rate was given to us. Okay. All right, and then the last one there says a rabbit population grows so that the first day there are 2 rabbits, second day there are 4, third day there are 8, graph the relation. Okay, so I'm just going to do I need to do axes. Obviously, we're not going to have any negatives. So I'll just put the vertical axis on the left. Horizontal axis at the bottom. So this would be number of rabbits okay, and this is the day number. So I do need to scale this for this application. So can I, let's count up how many grid markings I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the information, I go to 3 days and I have 8. So I could go up by ones. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. If I wanted to extend the pattern, I would need to change the scale and squish it down a little bit. Day 1, there's 2 rabbits. Day 2, there's 4. Day 3, there's 8. Take a straight edge. Can you join those up with a straight line? No. Okay. It's curved. It's kind of going up and then getting steeper as the days increase. What do you think the number of rabbits would be on day 4? Okay, hands up. Back, Brayden. 16. Because you keep multiplying by 2, right? So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, we're not adding 2 each time. So we've graphed it. Can we join the points? No, and the reason being, yes, time is continuous. We could have half of a day, but we can't have half of a rabbit, right? Or a quarter of a rabbit. So we can't have part values. So no, can't have part of a, it's easier to think about the rabbits in this case. Can't have part of a rabbit. So we just decided that we were multiplying by 2 each time, and it didn't form a straight line. So is the population increasing at a constant rate then? All the previous ones were straight line and they were constant. So this is not. So on the 7th day, so what did we just say? So we had the 4th day was 16. 5th day would be what? 32. 6th day would be 64. And so 7th day would be 128. Or another way of showing that, because you keep multiplying by 2, so that's an exponent. So 2 raised to the day number gives you how many rabbits? So that would be 2 to the 7 is equal to 128. Okay, so that's another way of calculating it. So in your package, you see a practice very similar, okay, to what we just did, both sides, and then a couple of practice sheets. Notice from the quiz from some of you, you have not been completing all your homework and checking it on D2L and asking me questions, because there's a lot of operations, order of operations questions that were not done as they should be.